Howdy, folks. Welcome back. And last time we were here, we had just put the pair cam in, and we're going to continue on with this. So we're going to go ahead and put in the pair cam riser. Expand risers, find the pair riser, put it in there. Good. And we're going to make that slider mate, which will click somewhere on there. And I'm going to click on the top there so that it slides. Good. I don't want another one, so make sure it works right and pull it up off of the cam a little bit. And we're going to use our tangent constraint to connect those two together. Our tangent mate, click on the bulb to make sure it's highlighted. You might have to click on it twice. Click on the surface it's going to go against. Make sure that that surface highlights all the way around. If it doesn't highlight all the way around, that means that you didn't do something right on the pair cam. You didn't make all of the parts that should be tangent to each other. So you may have to go back and fix that. All right, that looks good. Let's crank, see how it goes. There's a lot of math going on in the processor right now, so it could be a little bit glitchy. And all of this is going out over a server somewhere to make this happen. So it might be a little bit slow. All right, good. We got that going. Our next one that we're going to make is a Snail Cam, which is a little tricky. So here we go. Let's make a new part studio. And we are going to sketch on the right. We're not going to use variables this time. That would get a little complicated. And we're going to make a new sketch on the right. P turns off planes and gets me viewing perpendicular to it. And what's going to happen is we're going to make this guy, and just the distance from the minor part of the cam to the major part of the cam is just twice the distance. So we need to know that. All right, here we go. Back to our cam that we were working on. As we go, let's right click. I'm going to rename this just to make sure that I know where I am. Snail Cam. All right, and we're ready to go here. So this one's going to require a little bit of layout. So first of all, let's start by making a couple of lines, because I don't know what size things are right now. So I'm going to make a line, and we're going to start here, and we're going to come up. And let's make that first line 0.75. 0.75. All right. Now, let's make this line by clicking on it and coming up here, make it a construction line, because I don't want it to get in the way of things. Now we're going to need some points. So up above this line, we're going to hover there and make sure that yellow line shows up. I'm going to click up there, place that point, and dimension that point. Remember, it's twice the distance, so we're going to make that 1.5. All right, now we're going to place 3 more points. This is going to get a little bit tricky. So we're going to place 3 more points. We're going to hover over the middle and go out horizontal, somewhere right about there. We're going to dimension it in a minute. We're going to come down from the center right about there. We'll dimension that one in a minute, and a horizontal this way right about here. Okay. Now the distance between this and this is 3/4 of an inch. Okay. So we need to do a little bit of math here. And figure when we go from here, we're going to make some arcs, and those arcs need to get progressively bigger until they get to here. So each time we're going to increase by that 0.75 distance divided by 4. Okay. So let's go. I've got my calculator. 0.75 divided by 4 is 0.1875. So we're going to add that much to this one. So watch the magic. It's going to be a little bit complicated. Okay. So pay attention here. We're going to dimension the distance between here and here to be 0.75 plus 0.1875. Enter. So it's going to be a little bit more of a distance. Now we're going to dimension from the center point to this bottom one. I know it's getting a little crowded, but you'll figure it out. Now this is a little different. Watch. 0.75 plus 2 times, and it will do order of operation, so we don't need parentheses, 2 times 0.1875. Enter. Okay. Now we're going to dimension to this one. Dimension from here to here as 0.75 plus 3 times. Asterisk is the times 0.1875. Good. And we're getting progressively farther away from the center point as we go. Now, one last thing to do that's going to, actually, I'll do that in just a moment. So here we go. We're going to make our snail cam. To do this, we're going to use the 3-point arc up here. So there's a drop-down menu with different ones. We want the 3-point arc. We're going to start at this point right here that we made first. Click on that end, then come down here and click on this next point going counterclockwise. Click, and then you move your mouse to kind of set up what you, and you make the arc look about like that, about like a quarter circle. Click. Next one is going to start here. We're still in the 3-point arc command here, and go to this bottom one, click, and then we pull out and again make something looking similar to a quarter circle. Again, from this one to that one, and the last one from this one to that one. Let's make a line. And this line is just going to be used for reference. We're going to click here and make sure that it is horizontal. See that little line that shows up? We want to make sure that it is horizontal. Don't do the tangent thing. We want that little line to show up, and click. Just a short line. Doesn't matter how long it is. And we're going to use our tangent constraint up here several times. Tangent. The first thing I'm going to do is I'm going to make this line tangent to that arc. Okay. Now move down a little bit. You'll see that. The next thing is I'm going to make, still in the tangent command, I'm going to make this arc tangent to that arc. Now I'm going to make this arc tangent to that arc. And finally, this arc tangent to that arc. Looks good. All right, now the next part is something we're going to do to trick the computer. If we make this straight right here, the computer is going to freak out depending on which way we're turning the cam, because if we turn it a flat part up against something that's supposed to be tangent this way, it'll freak out and go, I don't know how you mean that, because that's impossible in the real world. So we're going to cheat a little bit on this. Now, this isn't the way the actual cams are made, but when you draw this line, we're going to draw it from this end point right here, not this one. Be careful. It's the first point that we made. Click. We're going to come up here, but we're not going to go to that point. We're going to go ever so slightly at an angle just inside, like that. Click. Now that line's going to be blue, and that's okay. And this is at a little bit of an angle, which is okay. Finally, last thing is we're going to make our hole for the shaft right on the center point. That is, again, 5/16. Good. Now, I know we haven't defined that, and that's okay. Let's go ahead and say check. And we're going to extrude this to 0.2. All right. There we go. Now, we are going to have to make sure that the riser has something to ride on that doesn't confuse it. So we already did this as a slope, but the next, we need to get rid of these sharp corners. So we're going to fillet this edge right here. And we're going to fillet that to the same as the diameter of the riser, which is 0.25. Enter. Now this bottom one needs to be a little bit bigger than the riser or it will get kind of stuck in there. So we're going to fillet that one, this little inside corner, which will fill in, but we're going to do that to 0.3. And we're looking good. Now this Snail Cam looks different than the Snail Cam that is in your kit, but we need it this way to be able to function. Let's go to part 1, right click, rename it, and call it Snail Cam. And let's make it whatever pretty color you want. I'm going to do purple. All right. Let's go to our assembly. Let's insert that thing, that Snail Cam that we just made. And we're going to do what we've done before with that constraint or the fasten mate. We're going to choose that center hole. And then you might have to flip things around to find where that is on the shaft and zoom in a little bit. There it is. Okay, so it's showing up. Make sure you don't choose other things like the pair cam stuff. Choose that shaft. And again, we're going to have to place it by going offsetting it along the Z-axis. Click on the view tube top so we're looking down. Now I discovered a new thing that's really cool. So I'm going to go, if your Z is pointing the other direction, it'll have to be negative. But I'm going to start by like 1.55 and do 2 decimal places. Hitting enter will highlight that. Now watch, I didn't know you could do this. Maybe some of you knew. You can spin your mouse wheel and actually change the values to get it close, which is really cool. Oh, except now it's got the spinning wheel of death. And Shazam, which hours later, because what had just happened is my internet went out for a long time and my phone and other things. I guess there were fiber optic cables that went out in my area. So anyway, we're back. Okay, so I've got that guy centered. Can see gaps on both sides, so we are all good. And now we're ready to put the riser in. Now to do this, I think I'm going to turn that, come on, get to the right spot. I'm going to turn that Snail Cam, turn the crank so it's a little bit away from there. And we're going to insert, expand the risers, and find the snail riser and put it on in there. And the same thing we've done before with the slider. There and there. And good. I don't need you anymore. And you should be figuring out what's going on. Tangent, bulb at the end. Click twice to make sure it's highlighted. Click the surface below it. Click, okay, and make sure it highlights all the way around. That means you did it right. Good. And let's test this thing. Now, the way we made this snail, we should be able to crank it both ways, even though that wouldn't happen in the real world. Okay, looking good. Now, let's test that. Yep. Now, that really wouldn't happen in the real world. It would bottom out right when it hit that. There's no way it would have enough to lift. But in the virtual world, because that's why we made that angle like that. Excellent. All right. So we're going to work on the custom cam a little bit later. So we're going to start with talking about what these things do. So there is a link in the assignment for you to go and get a part. And when you do that, you're going to get to stuff that I'm sharing with you. Make sure it shows the ruler. If it doesn't, there's a little tab on the bottom to say that says ruler on it. And then in the upper left, it says make a copy. You're going to click on make a copy. It's going to ask you if you want to make a new document, click OK, and then you can close that window that you were just in. And what will happen is you're going to when you go back into Onshape in here, you're going to have access to my document. So you're going to open that up, okay, find the ruler. We're going to right click and say move to document. And you're going to move to other documents. You're going to go to created by me and find your automata. Target version name doesn't matter. Just go ahead and leave it and hit move. Okay, and it says moving one tab to automata. Now, when you go back to your automata, so go back to Onshape, go back into your automata, and now you should have somewhere in here there it is, ruler. Ta-da! Okay, so if you didn't get that, go back through that process again. And now, by the way, you can go back to your Onshape. So when you're in my Onshape, and now you can just take this and just send it to the trash. You don't need it anymore, just to clean things up. If we need stuff from there again, I will just go through that process again. Back into our automata, back into our assembly. And now what we're going to do is we're going to do some evaluation of what these cams do and how they displace the motion, or how they displace the cams and how they turn the revolving motion into a linear motion. So we're going to put a ruler on here so we can kind of measure that. So here's how to do it. You're going to kind of flip around so that you see the left side of the box, and we're going to insert that ruler. Here it is. Now, I believe we're already looking at the back side. Let's make sure. I'm going to say, okay, good. That's what I want. And now what we're going to do is we're going to do a fasten mate, and we're going to mate the middle bottom of this, click, to the middle top of that. Click, and good. And now that ruler is there so we can see what's going on when one of these is going to go up and down, so we can actually measure what the displacement is of these things. Cool. All right, here we go with doing that. First of all, we're not going to do the Polygon Cam. The Polygon Cam is really used if you want to make something look like it's kind of just buzzing or vibrating. Like let's say you have a bee and you want it to look like it's just buzzing around. It doesn't really move that much. It just sort of jiggles. And it's not really that easy to map that out. So let's get rid of that one. And what we're going to do is we're just simply going to turn off what we don't want to see. So we're going to turn off the visibility of the Polygon Cam and the Polygon riser. And while we're at it, let's go ahead and turn the visibility off of, I guess I never named the pair cam. I'm going to go do that right now. Let's go into pair cam. I don't know if you did this, but I forgot. I'm going to rename that as pair cam. This is why it's important to name things, because then you know what you're doing in your browser. Back in the assembly. So now I know I need to turn off the pair cam, so pair cam, the pair riser. I'm going to, while I'm at it, turn off the snail cam and the snail riser. All right. So we are now going to make sure again that it's at its lowest point when we are when this handle is straight up. So now let's take a look at the right side view, and just for fun, just turn the handle and see what happens. We're going from about a 1/2 inch lowest to close to 1.5 inches at its highest. All right, switch screen so I can show you what we're doing with this. So we're going to take a look at the right. I'll click on the right side of the view cube so we're looking straight on. We're going to come over here to find the crank. And the first thing we're going to do is make sure it's straight up and down. Right click and hit reset. And what it'll do is move that straight up and down to what the first setting is. All right, now what we're going to be doing is we're going to plot out what this is, the motion that this has in a graph. And so you have a slides, a Google Slides that's shared with you. And the first thing we're doing is graphing the eccentric cam. So let's do that. Let's think about what it's going to do. It's starting at a half of an inch off of the deck. We're going to have to change that a little bit. In fact, I think before I do that, let's remember what that does. It goes up to about 1.5. So that's good. We may have to make some alterations on the next one. I'm going to come back to crank and reset it again. Should have gone to the top. Let me try that one more time. Reset. Oh, that's interesting. I thought that it would go to 0. Crank, reset. There. Weird. Anyway, here we go. We're going to go look directly at this thing, and we're going to plot out what it does. It should make a nice smooth motion up and smooth motion down because it's always going to change the displacement. So let's go with what we know is at 0 degrees, we are at a half an inch. Okay. Now we're going to flip back and forth from this to the other one and hope that this works out. So we're going to start by drawing on this slide, choose a curve. Now, if this doesn't work out with flipping back and forth, and we're starting at 0 degrees, we start at 0.5. We come back here. Now, this isn't going to work out. Okay, I wasn't sure how we're going to do this. So let's grab a piece of scratch paper, and I'm going to write some things down. We're going to write down where this is at 0, 45, 90, 135, 180, 225, 275, and 360 is the same as 0. So make yourself a little list. I'm doing that on a piece of scratch paper. 0, 45, 90, 135, 180, 225, 270, 315, and then 360 will be the same at 0. So at 0, we're at 0.5 inches. We're at 1/2 inch. Okay. Now, here's how you get the rest of your data. We're going to go to crank. We're going to right click on that. Okay. And actually, I'm sorry. Right click on it and animate. Okay. Now, what we're going to do is right now our start value is at 0 and our end value is at 360. We want our end value to be 45. Okay. And we're going to play. Now, if it goes the wrong way, nope, it's going the right way. Boy, it's going slow because it's 300 steps to get there. We'll slow that down on the next one. Oh, and I've got it on reciprocate. I want it loop. Let's try that again. Let's put it down to like 50 steps. Okay, it'll go a little faster that way. And I don't want it to loop actually. I want it to do single. Okay, so make sure you got these numbers just like this. Starting at 0, going to 45, 50 steps, and we're going a single time. It moves over there. Now it moved up to about, let's call that 1 5/8. Now go ahead and, so I'm going to write 1 5/8. Now you have to remember how to read a ruler. That's why we just spent all that time doing it. Now I'm going to change it to 90 degrees and we're going to play it again. Okay. This time it goes to 7/8. Now we're going to go to 135 degrees. Play. And it's going to go to 1 5/16. I think is closest. We'll go to the nearest 16th of an inch. 180 degrees. And play. And that is going to 1.5. Now, if you're smart, you already know what's going to happen. It's going to be a mirror image of what we just did, right? Because it's symmetrical. So we could do that again and go through the whole process and put in 225 degrees. 225, but I already know that it's going to be 1 5/16, okay, because it's symmetrical to the other side, right? So it's just on its way back down. So 225 is 1 5/16. 270 is again the mirror image, which would be the mirror image of 90, which will be 7/8. Okay, and 315 will be the mirror image of 45, which is going to be 1 5/8. All right, so now that we've got our values, we're ready to plot out what this would look like on a motion graph. So here we go. We're back to our cam motion analysis. Choose curve. We're going to start at 0.5. At 45, it's 5/8, which is each one of these is a fourth. So this would be 4/8. This would be 6/8. There's 5/8. Whoops, I meant to do that at the 45. I'm going to try that over again. Here's the 45, which is 5/8. At 90, it's at 7/8, which is here. At 135, it's at 1 5/16. So this is 1 4/16. That's about 1 5/16. At 180, it's at 1.5. Click. At 225, it is opposite of the other side. We're back to 1 5/16. 270, we're back to 7/8, which is here-ish. 315, we're going to be at 1 5/8, or sorry, at 5/8, which is right about here. And when we get to the end, we're back to the 1/2 inch. Click. And finally, don't move your mouse. You're just going to click on the end one more time. Click, and it will make that for us. Now, just so it's nice and bold, let's go up here to our line color. Make that some dramatic color, whatever you like. I'm going to make it red. And let's make our point value like 4 point so it looks really good. So here's our motion of the graph. Next class, we will work on the motion of the pair cam. All right. Hope you're enjoying it. I'll see you next time.